Hello students, from chapter number 12 electricity we discussed about Ohm's law, and in the previous video lesson we discussed about the constant of proportionality in Ohm's law, that is the resistance of the conductor of given material. We discussed that resistance is opposition to the flow of electric current in an electrical circuit. When we have to show resistor in an electrical circuit, we use this symbol, and it's very important to note that the device which is used in an electrical circuit is resistor, and its property to oppose the flow of electric current is called as resistance. So we can say that resistance is a measure of opposition of current flowing in an electrical circuit. This resistance is measured in ohms, and the symbol of ohms is omega. This unit for resistance is given as ohm so as to honor the work of Sir George Simon Ohm, who is pioneer in inventing Ohm's law. Now, opposition to the flow of electric current sounds slightly negative for the resistance, but it is not like that. Resistance is very important in case of an electrical circuit because it controls the flow of electric current in an electrical circuit. Now, if the value of resistor is more in an electrical circuit, then the current flowing through the circuit is less. If the value of resistor is less in an electrical circuit, then the current flowing through the circuit is more. So this is how we can say that the electric current and the resistance is inversely proportional to each other. So the resistors looks like this. You must have seen this on the motherboard of many electrical appliances like the transistor, television, washing machine, fridge, your laptops, any electrical device you take. On the motherboard of electrical device, we see resistors like this, and the colored bands which you can see there on every resistor gives its value. Now, how to find out the value of every resistor? This you are going to learn in your higher classes. This is just to show you that the resistors looks like how it is shown in the given figure. We also discussed that resistance of a conductor depends upon certain factors. First factor is the length of the conductor. So the resistance is directly proportional to the length of the conductor. As we increase the length of the conducting wire, its resistance increases. Second factor is area of cross section. Resistance is inversely proportional to area of cross section. As you increase the area of cross section, the resistance of that conductor decreases. The third factor is material of the conductor. So the resistance of the conductor changes according to the material which we have used. Then we discussed one formula that R is directly proportional to L and it is inversely proportional to A, that is the area of cross section. And here the constant of proportionality is denoted by symbol rho. So the rho is constant of proportionality, which is called as resistivity of the material of the given conductor. This resistivity of the given material is measured in terms of the unit, which is ohm meter. So I can say that SI unit of resistivity is ohm meter. Then a very important factor we discussed, that the resistivity of conductor is less than the resistivity of an alloy, which is also less than the resistivity of the insulator. Meaning is that the resistance of the insulator is highest. Alloys also have certain amount of resistance. For example, yesterday we were discussing about the nichrome wire, which is an alloy, and conductors like copper, they have the least resistance. So maximum amount of electric current can pass through the conductors. Children, when we were discussing about an electric current, we discussed about a device that is an ammeter. Ammeter is an electrical device which is used to measure electric current in an electrical circuit. The figure which is flashing here on the screen is an ammeter, and the red color screw is positive terminal of an ammeter and the black screw is the negative terminal of an ammeter. When we have to show this ammeter in an electrical circuit, we have to make use of the symbol, and this is the symbol for ammeter. Now, according to the polarity which is shown here on an ammeter, we will make a symbol in this manner. When we discussed about potential difference, we also discussed about a device which is called as voltmeter, and voltmeter is a device which is used to measure electric potential difference between the 2 points in an electrical circuit. When we have to draw voltmeter in an electrical circuit, we have to make use of the symbol, and this is the symbol. And according to the polarity which we can see here on the figure which is flashing on the screen, our voltmeter will look like this. When we discussed this, I told you one very important property about ammeter and voltmeter, and today we are going to discuss about it. I told you that ammeter is always connected in series with the circuit. Now the purpose of ammeter is to measure electric current in the circuit. So when we connect this ammeter in an electrical circuit in series, it measures the amount of current flowing through the circuit. This is because the resistance of the ammeter is very low. It is nearly equal to 0. Hence, whatever current is flowing through the electrical circuit, it is measured in an ammeter. Then I told you that voltmeter is always connected in parallel with a device to measure the voltage. So in an electrical circuit, whichever devices we are using, say if we are using a resistor or an electric bulb or whatever device we use in an electrical circuit, when we have to find how much voltage is there across this device, we have to connect the voltmeter in parallel. Now this is because the voltmeter is used only to measure the potential difference. And the very important thing is the resistance of the voltmeter is very high. So when we connect the voltmeter in parallel, hardly any very fractional amount of electric current flows through it, because since the resistance is high, it opposes the flow of electric current through it. So it measures only the potential difference. Now when I say that ammeter is connected in series, voltmeter is connected in parallel, exactly how it looks like, let's see this with the help of the figure. So we will draw a figure, and the figure will have an ammeter, voltmeter, resistor, battery and a key. I will explain you how to draw the electric circuit. There is no rules for drawing an electrical circuit. Any component can be anywhere in an electrical circuit. But the rule which you have to follow is ammeter should be in series and voltmeter should be in parallel. So we'll start drawing an electrical circuit with the help of a battery. You can see this battery with positive and negative terminal. Then after the battery, we will draw an ammeter which will measure the current flowing through the circuit. After that, we will draw here the resistor in an electrical circuit, and then we will complete the circuit by drawing the plug key or a switch. Now if you can see, I have connected ammeter immediately after the battery. Alright, then when I have to connect the voltmeter in an electrical circuit, I said it should be connected in parallel, and the meaning of parallel is it has to be connected across the device, and in our case we have made use of the device that is the resistor, and across the resistor we have connected the voltmeter. So this is how we will say that voltmeter is connected in parallel. Then we have to show the direction of flow of electric current. So I told you that we will always show the direction of flow of electric current from positive terminal of the battery to the negative terminal of the battery. And the electric current will flow through the circuit only if the plug key is on. So this is how you will draw the circuit diagram. Now if you observe here, the positive terminal of the battery is connected to the positive terminal of an ammeter. And when I say that ammeter is connected in series, we have to always be careful that positive of the battery should go to positive of an ammeter. Then and only then we say that it is in series with the circuit. Now suppose you use the battery in this manner, the polarity is different. Now here is positive terminal and the other is negative terminal like this. You have reversed the polarity of the battery. In that case, you will connect the ammeter in such a manner that negative terminal of the battery is going to the negative terminal of an ammeter. So an voltmeter will be accordingly placed like this. You have to keep in mind that the polarity of the voltmeter should match with the polarity of the battery. Now here you can observe that the negative terminal of the battery is connected to negative terminal of an ammeter because it is connected in series with the circuit. Then these 2 points are the 2 points across which we are measuring the potential difference. Now when you are connecting the battery in the other way, changing the polarity, now what is wrong in the circuit? Can you guess it, or the circuit is correct? The circuit is definitely not correct because the direction of flow of electric current will change now. The flow of electric current is from positive terminal to the negative terminal of the battery, and now it will be in the opposite direction like this. So this is how you can draw the diagram for an electrical circuit. Now suppose if I connect the voltmeter in series with the circuit, what will happen? Because we have a rule that voltmeter should always be connected in parallel. If you connect voltmeter in series like this, the current will not pass through the voltmeter because I told you that the resistance of the voltmeter is very high. So when the current will start flowing through the battery, it will stop there because it has very high resistance. And suppose if I connect an ammeter parallel to the circuit, parallel across the resistor, it will draw the whole of the electric current flowing through the circuit and ultimately it will burst. Hence, ammeter is never connected in parallel with the circuit because ammeter has very low resistance, and so maximum amount of current can pass through an ammeter. Now suppose if I want to find out how much is the voltage of this battery, because I don't know, I want to find out how much volt is this. What will I do? I will connect a voltmeter across the 2 terminals of the battery the way I'm showing you, and I can measure how much volt is this battery is. So this is how whichever device is connected in an electrical circuit, we can measure the voltage across that device by connecting a voltmeter in parallel across it. Now it's not a rule that I have to connect this ammeter, voltmeter, battery, plug key in a specific manner when I draw an electrical circuit. You can draw all these devices anywhere you want, only you have to keep in mind the rules that voltmeter should be in parallel and ammeter should be in series. So let's have a look at the figure wherein the components are drawn in some other places. In this circuit you can see that the battery, ammeter and voltmeter is drawn in some other manner. So it is absolutely alright. Only thing, you have to follow the instructions that ammeter should be in series with the circuit. That means positive of the battery should go to positive of an ammeter, or negative of the battery should go to negative of an ammeter. And the voltmeter should always be across the device in an electrical circuit. Polarity of the voltmeter should match with the polarity of the battery. So it's all your wish where you want to place the device, only by following the rules. I want to tell you about one device that is a multimeter, and the name itself suggests that it is a multi-purpose device. Now in an electrical circuit we have separately made use of the ammeter and voltmeter to measure the current and the voltage, but if we make use of multimeter, this multimeter can be used for measuring the current, the voltage, the value of the resistor. Everything we can measure with the help of multimeter. The red and black color two wires, those are called as the probes of the multimeter. So, and down you can see some slots wherein you have to fix these probes and find the value of current, voltage, resistance in the circuit. So the other figure will give you an idea about how it is measured. These two probes, you can see that one is the positive terminal, one is the negative terminal, and the probes you just have to fix between the 2 points of the device and it will give you digital value. So this is the new thing. You must have seen this with the electricians who are coming to your place for the repair work. So this is a multi-purpose device. We have this in our laboratory. When we will visit our laboratory, I will show you this device. So this is all, children, for today's session, and in the next session see you all with a new topic. Till then, bye and take care.